Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. In this video, we're going to discuss the rectangle collision point enum. So let's right-click our collision folder. Let's go to Add Class, and we're going to call it Rectangle Collision Point, and replace class with public enum. So these are going to hold our points of collision. Last tutorial we discussed the side. We only have 4 sides of a rectangle, but we have more than 4 points of collision in a rectangle. So let's set none. We don't have a collision. Top, left, bottom, right. But those are sides. We're also going to have those combined. We're going to have top left, top right, bottom left, and bottom right. So not only do we have sides for the collision point, but we have corners for the collision point as well. Alright. Since those last tutorial and this tutorial are very short, I'm going to combine this with the Rectangle Collision Point extension class. So let's right-click our collision folder and let's go to Add Class. We're going to call this RectangleCollisionPointEx, or whatever your naming convention is for extension method classes. It's going to be a public static class, RectangleCollisionPointEx. So the first thing we need to create is we need to combine. We need to somehow get from left and top. We need to combine those two top left corner, and we need to do the same for all the other corners as well. So let's set up a public static rectangle collision point. We're going to call this combine. We're going to combine 2 points into a corner. This rectangle point source and rectangle collision point target. So we're going to combine source and target into a corner. So if two opening parentheses, source is equal to rectangle collision point dot left, and target is equal to rectangle collision point dot top, after the first closing parentheses or opening closing parentheses, and then in between those parentheses, source is equal to rectangle collision point top, and target dot rectangle collision point, or is equal to rectangle collision point left. And I'm going to move this to a new line here. Closing parentheses and opening closing the curly brackets there. We're going to return rectangle collision point top left. So what we did here is we checked to see if source is left and target is top, or source is top and target is left. We are going to return top left corner. We need to do the same thing for all the other corners. So we can copy this if block here and paste it below. And change So we have if source is equal to RectangleCollisionPoint.left, change .left to .right, and target is equal to top, that's fine. In the second line, we have source is equal to RectangleCollisionPoint.top, that's fine, and target is equal to RectangleCollisionPoint.left, change left to right, and change our return to top right. Now what we can do is copy and paste those two if blocks. And I'm going to separate those so it's easier to distinguish which ones we've done and which ones we haven't. In the first one we pasted, we have left top and top left. Change that to left bottom and bottom left. And our return type is bottom left. In the second if block that we pasted, we have right top, top right. Change that to right bottom and bottom right. And our return is going to be bottom right corner. If none of those have succeeded, we are just going to return no collision. This is only going to be called when we have a valid check. We have checked to see if rectangle collision point is on a side for both source and target. So if they're both on a side, we can combine those. The next thing we want to do is have a public static vector2 get corner normal. Vector2 delta. What this does is we are going to find a corner value of our object, and we want to return a normal for that corner. Var n is equal to delta, n.normalize, return n. So that just gets a normal of the vector2 we pass, and that's going to be a corner that we pass. This would be more obvious when we generate this method here. Public static vector to get normal. This rectangle collision point bool inside is equal to false. That's going to be an optional parameter, because normal inside is going to be different than a normal outside. Game math video coming up in a future video. Let's switch on our provided point. Okay. Case. If we are at the top, we simply return new vector2, 0, comma, is it inside? If it is, 1, otherwise -1. Basically, imagine you are holding up your phone or your keyboard, or you're looking at your keyboard, and at the top of your keyboard you have your number keys or your function keys. So put your finger on one of the numbers or function keys, and then move your finger towards the top of the keyboard and move it past the keyboard. Now move that back to the keyboard. As soon as you are over the keyboard, That's the normal we want. The normal will return the opposite direction of where you are coming from. So if you're coming from the top, you're going positive y. So our normal is going to be the opposite, so it's going to be negative y, and the normal has a length of 1. That is this here. We are not on the inside. Now, hold your finger to one of the number keys, or letter keys, and then start moving your finger towards the top of the keyboard. Right before your finger passes the top of the keyboard, that is another collision where we are inside that keyboard, but we are moving our finger negative y. So our normal needs to be the opposite. It needs to be positive y, and normals have a length of 1. That's where inside is true comes into play. So there will be a video that you will see that will discuss that, give you more visual of what is going on. Okay, case, left, return new vector 2. If it's inside, we're going to return 1. Otherwise, we're going to return negative 1. And 0 for the y. Case. Bottom. If it's bottom, we are going to return new vector 2. If it's the inside, we're 0 for the x. If it is inside, we're going to provide negative 1. Otherwise, we're going to provide 1. Case. The right corner. Return new vector 2. If it is inside, we are going to provide negative 1. Otherwise, we're going to provide 1 and 0 for the y. Now is where the corners come into play and where this method we created before comes into play. Case. Rectangle. Top left. We want to test the top left. Return. Get corner normal. New vector 2. If it is inside, we're going to provide negative 1 for the x. If it is outside, we're going to provide positive 1 for the x. For the y, if it is inside, we're going to provide negative 1. If it is outside, we're just going to provide positive 1. So that is top left. Remember, a vector has to be a length of 1. So a 1, 1 vector does not have a length of 1. That's why we need to normalize our corner vector. Case. We're going to test our top right. So our top right corner. Return get corner normal. New vector 2. For the x component, if it is inside, we're going to return 1. Otherwise, we're going to return negative 1 for x. For y, if it is inside, it's going to be negative 1. If it is outside, it's going to be 1. Case. Bottom left. Return get corner normal. New vector 2. If the x is inside, we're going to get negative 1. Otherwise, we're going to get 1. If y is inside, we're going to get 1. Otherwise, we're going to get negative 1. Case. We're going to get the bottom left, or yeah, bottom right corner now. Return get corner normal. New vector 2. Inside 1. -1, inside 1, -1. Default. We did not satisfy any of those conditions. We're going to return vector2.0. So that is it for that method. We're going to have one more method here. Public static rectangle collision side. We're going to get a rectangle collision side from our rectangle collision point. Get collision side. This rectangle collision point source. Switch our source case. Rectangle collision point bottom left corner. And case rectangle collision point left. And case rectangle collision point top left. We're going to return the left side. Case rectangle collision point bottom right. Case rectangle collision point right. Case rectangle collision point bottom right or top right. Return collision point right. Collision side right. Case collision point top. We're going to return rectangle collision side top. Case collision point bottom. Return collision side bottom. Default. Return no collision. Alright, so this just converts our point to a side. Now the corners are a little bit iffy depending on what you want to do. Like the bottom left, bottom right, and top right. I chose to set those up to be the left or right sides, not the top or bottom. Depending on what your situation allows, or if you have a better thing you want to do for this, feel free to do that. So that is it for this tutorial. I hope you enjoyed it. Next video, we are going to discuss the movable entity class. So I hope to see you next time.